Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to write the domain in interval notation. In a previous video, we discussed what the domain or the inputs of our functions were, and in this one, we're just going to show us how to write that in interval notation. So here, we said that our inputs of this function could be any real number. So to show that in interval notation, that means our x values could be as small as negative infinity, all the way to positive infinity. In other words, our x value can be anything in between. It can be in between negative infinity to positive infinity. And we put parentheses around that. Those parentheses mean not included, or that we don't make it there. You know, we never make it to negative infinity, so we use those parentheses. And in interval notation, we always put our smallest number first, and then our largest number that our x value can be, or our input can be last. So there's the interval. Our x can be anything on this interval from negative infinity to positive infinity. Anytime we have all real numbers, this is our interval notation. Here, the interval notation, our x, the smallest number that our x can be, or the smallest input for our x value, is -4. And then the largest number that our input can be, well, it goes on and on and on forever. So we say that the largest input then is infinity. So our x value can go anywhere from -4 out to infinity. And to show that that -4 is included, it is a value that has an output on the graph, we're going to use a bracket around it. So anytime it is included, or there is an output, we use the bracket. When it's not, then we use the parentheses. So, you know, we'll never make it out to infinity to put that point on there. So we use a parentheses there. So this just says that our x value can be anything from -4, it can be equal to -4, all the way out to infinity. Here, our smallest x value, well, it gets, you know, closer and closer and closer to -5. It never makes it down to -5, but it gets closer and closer and closer to that. So to show that, we're going to go ahead and put -5, but because it's not actually got an output there, it gets closer and closer and closer to it, we're going to use a parentheses there as our symbol to show that it's not included. Now the reason we use -5 is because it's getting really, really close to it. I can't put -4.9 because I could get closer to -5 there. I could put -4.99. Oh, but wait a minute, maybe we should use -4.999 or -4.9999999. I'm gonna have to stop somewhere, and it just keeps getting closer and closer and closer. So that's the reason we use this -5, but we put this parentheses to let us know that there's not an output right there, that it's just getting really close to it. Then the largest value that our x can be is 0. So, and it can be anything in between. Our x value, or our domain, is anything between -5 and 0. Now, it does have an output at 0. So to show that it does have an output there at 0, we put the bracket. So again, if this is actually included in the domain, we use a bracket. When it's not included, we use a parentheses. So this is anything in between -5 and 0 with 0 included as part of our domain. On this last one, we really have 3 pieces to our graph. Here we have from negative infinity, the smallest thing we can be out there is negative infinity, and the graph goes all the way up to here at -1. So this is one piece of our graph. Then we have another piece that starts on the other side of -1 and comes down forever and ever and ever, gets closer and closer and closer to that 1 without ever hitting it. So this is a second piece to our graph. And then this one, you know, is our third piece to our graph. We start where it's getting closer and closer to 1 but never hitting it. And then it goes and goes forever and ever out towards infinity. So there are 3 pieces here, 1, 2, 3. Another way to look at this is we said that this can be any real number. So just like I did over here when I said any real number, I went from negative infinity out to positive infinity. I'm going to do that same thing here, but we said it can't be negative 1. So to show that it can't be negative 1, I'm going to say it goes from negative infinity to negative 1, but that negative 1 is not included. So that's like the first piece of my graph. I'm going to union that with, that's a little union symbol, with negative 1. So this piece goes from negative 1 to 1. It doesn't quite make it there to 1, but it gets close. So negative 1. So it can't be negative 1. Notice that my negative 1 is not included. Then the next thing that's not included is the 1. So now it gets close to 1, but there's no output there at 1. So because my 1's not included, again, I use a parenthesis. And then I start again on the other side. From 1, it gets close to 1 but doesn't hit it, out to infinity. Or you could just think of it as I go from negative infinity out to positive infinity, but my graph, my x value, my domain can't be at negative 1. I skip over negative 1, and I skip over 1. So there's my domain in interval notation for all 4 of those functions. So we looked at it in set builder notation, we looked at it in interval notation. In our next video, we're going to look at the range or the y values or the outputs of these functions. Math made simple at Simpson Math. Thanks for watching.